sometimes kids find it easy to graph the parent curve, the regular curve from this. This would be the same as my cosine 1/2 x. Like if you graph the cosine curve for this, you can graph off your secant. I'll show you both ways to do this, and algebraically to find your domain. Here's my regular curve up to 2 pi. My period for this one, when my frequency is 1/2, is what? What's my period if I'm doing half of my curve in 2 pi? 4 pi, right? I'm just going to extend this to 4 pi. I'm not going to do the negative side. Let's just give the basic parts. Now, I'm going to go through my cosine curve. Here's my cosine curve. Do we agree? Okay? Half of my curve in 2 pi. I spread it out because otherwise if I leave it at half, you're going to see half of your secant curve, which isn't going to help you any. Now, again, it comes down on this side and it crosses. Wherever it crosses the x-axis, it's where your asymptote is. Because when x is 0, 0 over 1, when we flip it over, it's 1 over 0. We can't do that. This is where your asymptote is. So now you should see a pattern for your domain. And your curve is going to go off of these peaks. Now, you can find your domain from here if you need to, if you can't remember this part. So you can say, okay, my domain is real, except when x is equal to 1 pi, 3 pi, 5 pi, 7 pi, n pi, where n is an odd integer. If you don't have this, write this down. Where n is an odd integer. Aren't I at the odd pi's?
Yeah.
Yes. Now, if you remember that your secant and your tangent all have the same basic domain, the two of them, and pi over 2, because the tangent's the easiest one to remember, isn't it? Because when we do tangent, isn't it the pi over 2, the negative pi over 2 asymptotes? That's the easy one to remember, where n is an odd integer. If you take this and you replace it with the x, with this qualifier, you will get your domain. Now solve for x. They have the same denominator, so therefore the numerators are the same, right? Didn't we get the same exact as we found here? Okay. Did we change the range of your secant curve from your original cosine curve? No. So your range is still good. -1. Good. Now, if you can do this part, if you don't do any of the graphing, but you cut to this one right away, watch what happens. If I know where my asymptotes are, can I say, okay, this is pi, this is 2 pi, 3 pi, let me just go to 4 pi. If I know where my asymptotes are, can I say, okay, at the pi, at the 3 pi, I know that my range is going from 1. Can I say from the 1 to the -1? All I have to know is where am I starting? Where am I up? Where am I down? Just picture your cosine curve. Your cosine curve starts up here, doesn't it? So this guy is going to go up here. This guy is going to go down here. This guy is going to go up here. Can I do that as well? Yeah, you're only giving me a sketch. But I find two things, that you have to know this one. You have to know the original one to get here. And then you have to just visualize where it starts. Because you can't start this guy going in the middle up. It's got to be where your cosine curve starts. We have this? We understand this? Okay? Let's take a look at your tangent curve. Now, tangent, it's not continuous, but your tangent originally works real nicely. So if it's helpful to you, put your original curve here. Your original curve has asymptotes here at the pi over 2. This is pi over 2, pi. So our original tangent curve went like this through the 0, right? So it's going to pass through the 0. 1/2 on your cosine curve said 1/2 the curve in 2 pi. So didn't our period double, right? Instead of 2 pi, we went 4 pi. So if our period for tangent is pi, and I'm going to do 1/2 the curve in pi, what's my period going to be?
2 pi.
2 pi. So instead of being here at the pi over 2, I'm going to double this. It's going to go to pi. So now my asymptote is right here. Oops, sorry, not this one. And my tangent curve is going to spread out. Doesn't it stretch? Because of the 1/2, right? So I might be able to figure this out. I noticed this was my 0, this is my 2 pi. Where else is my asymptote going to be?
Starting at that one.
At my 1 pi, and then where else? At my 3 pi? Okay, because my other curve has to spread out. So at my 3 pi, I get another one. So can you give me your domain? N, pi, and odd integer. See it? I like the tangent. It's not continuous, I get it. But its period is right smack in the middle. Yes?
It's not pi over 2.
Well, not on this one. Not on our new one. Because look where my asymptote is. At the 1 pi, at the 3 pi. If you're going to do it this way, and depend on your graph, you're going to take it off of here. However, John, if you're going to take it off your original tangent curve, you're going to start like this. And pi over 2, where n is an odd integer. Then you're going to take this side and replace it with x over 2. Then you're going to solve for x. So x is n pi, where n is an odd integer. You can get it either way. Algebraically is nice, but you have to remember the original one. If you forget your original one, the tangent is nice because when the tangent shrinks and stretches, it starts right at the origin. We're not moving anything over. It starts right there. It's still going like that. Whether it's pushed in going like that or it's spread out going like that, it still starts in the middle. Okay, now, before I move this one, here this guy says a 2 pi, 2x. It means I need to have 2 tangent curves in the time it takes me to have one, right? 2 cosine curves in the time it takes me for 2 pi. 2 tangent curves in the time it takes me for the tangent period, which is pi. So if my period is pi for my normal tangent curve, and I need to put 2 curves in there, my period is now going to be pi over 2. But watch, I'm spread from the 0. So if I want to go pi over 2, how far out do I go on the left and how far out do I go on the right to make this be equal to pi over 2? This is 90 degrees. How far out should I go to the left and to the right so that this period is 90 degrees? Give me degrees. 45. If I go 45 out here and 45 out here, pi over 4. Pi over 4. Do you see it now? Negative pi over 4. Do you see where I have to go? From here to here. This has to be where my asymptote is. And now I got to put this little one right in here. The little one is going to go right in between those two. Don't I need to fit double the amount in this space? so my period is less. What I'm looking for is these guys. This is 1 pi over 4. I need to see when's my next one. So if this is another pi over 4, and there's another one over here, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, you're going to get another one that goes in here. You guys see, don't I have to have double the amount in here? I have to have double the amount. So I could say it's n pi over 4, where n is an odd integer. My domain. Now, I don't have to do that. I could take this. We already know what our domain is. Set 2x equal to this. Cross multiply. Stay with me. And divide by 4. Look at that. N pi over 4, where n is an odd integer. So if I can't really see it when I graph it, can I solve it by knowing what my original domain is? But what I want you guys to see in your own heads is, when am I stretching? When am I shrinking? When am I doubling my period? When am I halving my period? Because that's going to help you on your tangent with your asymptotes. Your tangent is nice. Your cotangent is not nice. But your tangent is nice because your tangent stays smack at the middle. So if it's going 45 degrees to the left, it's got to go 45 degrees to the right. And I'm going to pick that piece up and keep on going with it. Your cotangent, unfortunately, starts to the right, not in the middle. So the cotangent's a little bit harder than the tangent. But the tangent's kind of nice. Are we feeling this? No? Can you do this part? Take the original and change it? You got to memorize the original one. You got to memorize your original domain. But let me just take this off. Tangent, again, is easy to memorize. Your tangent curve, here it is at the pi over 2. Can you take the tangent of 90? No. Your tangent curve is here. The tangent curve is nice because look at the period. The period is pi. And it's equal to the left as it is to the right. If I have to take half of that period, it now has to go in half of the space, doesn't it? I got to cut the space in half. I got to make my asymptotes halfway. Oh, half of 90 is 45. And I'm here. Instead of n pi over 2 where it's odd, I'm n pi over 4 where it's odd. See it? If I'm going to stretch it 2, instead of n pi over 2, double it. I'm n pi where it's odd. To me, that kind of makes sense to do it that way.
So the larger the number gets, the smaller.
Yeah, smaller the space. Right, because you got to fit that many more in that same space. Okay, this one should not have been so bad. What changed? Did my frequency change? The amplitude changes. So should my domain change for my cosecant curve? No. So either you memorized it and you knew that it was real, except when x is n pi, where n is any integer because it begins with a c, or you did this, you gave me your sine curve. I'll just do the positive side. It's going to go up to 2. My sine is going to go here, 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 here. It went up to 2. I can find my zeros here, here, here. So I did 0, pi, 2 pi. Do you see the pattern? So I can't use 3 pi, 4 pi, and pi. And this is also 0 pi. 0 is an integer, where n is any integer. You have to qualify this, because if I just say n pi, it could be 1.7, but it can't have it be 1.7. So if you can get that far, you're good. Now, the only other thing that changed was my range. Now my sine curve goes from 2 to positive 2, negative 2 to positive 2. So my domain of my cosecant is going to go negative infinity to negative 2, and from 2 to infinity. See it? So you can sketch it, or you can memorize it. You really only have two things to memorize. You don't have to memorize a lot. You only have two to memorize. The tangent and the secant work the same. The cosine and the cosecant work the same. The cotangent.
Is it supposed to be the range where you put negatives underneath the two?
Yes. Oh, and I put a date. Thank you. Thanks, Camille. Keep track of me. So we've got our domain and we have our range for this guy. Now what's happening in this next one? What transformation is happening in this one? A reflection. Is that going to change my domain? Not at all, because this is a continuous curve. My domain is still going to fall wherever it falls. Is it going to change my range? Not at all. So I could either say, okay, I know what my domain is for my cosecant. It's all real except n pi, where n is any integer. And I know my original range because my sine and my cosine curve go from 1 to negative 1. This guy is the opposite. Or I can sketch it. If I sketch it, I'll sketch my sine curve first. That we can do, right? Everybody can do their sine curves. What happens with the negative? What does that do to me first? Down. So all you need is your basic curve. Ah, can you see where your asymptotes are? At your zeros. What you might want to do is just label the pieces. Oh, I could see at the 0 pi, at 1 pi, at the 2 pi, I could find my domain. And can I find my range also? Absolutely. I could find my range as well. But all there are is groupings of 2. I was hoping that you would see that last night when I said look this over. Okay, and the very last one that you had, it said half, I want half of my curve to 2 pi. So think about your cosine curve, your cosecant curve. It says n pi. Am I shrinking this in the asymptote, or am I spreading it out? Spreading it out. So when I use the half, I'm really doubling the space I need, right? So technically, what should my new domain say? Twice that, 2n pi. So let's see if that's true. I take this, and I set this equal to n pi, where n is any integer. I cross multiply. Just like John said, 2 and pi. This pulls me up my even ones, because we don't really ever say even. We just use n as any integer or n as any odd. So this will help us. Now, if you struggle with this, do your sine curve. Make your sine off of this. Your sine curve says half of my curve in 2 pi. This is pi. I'm just going to go 4 pi so you can see it. Let's just do the 4 pi out, because it's going to take me 4 pi, right, to complete the whole sine curve. So here, 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 and here. So look where your asymptotes are. Here, here, and here. I'm sorry, I missed the 4 pi. Isn't it all the even numbers? 0, 2, 4, 6, 8. And I would go up like these guys. Spread them out. Okay. So when you can't get it, the sketch will help. The sketch will help. Did I change the range on this, by the way? No. Your range is still negative infinity to negative 1 and 1 to infinity. Now, when you do this tonight,